Welcome to the InfoCAD video tutorial. In this video, a safety analysis of an embankment is shown. The classical Mohr-Coulomb model is used in order to capture the nonlinear material behavior of the soil. After defining all required soil parameters, the slope stability is assessed by means of the so-called Phi-C reduction method. Subsequently, in a second analysis, the computed values of friction angle and cohesion are set below their limits to activate slope failure. Deformation figures and plastic strain distributions are also shown. First, the soil parameters are customized. For setting these parameters, please select the material type, free, within the dialog of the material properties. Different nonlinear material models are implemented in InfoCAD. In order to simulate the failure of slopes or compute the factor of safety, we select the Mohr-Coulomb plasticity model. In a next step, we customize or accept the default values of the three parameters that affect the soil failure: the friction angle, the dilatancy angle, and the cohesion. Please note that the corresponding uniaxial stress-strain relation can also be visualized. Please choose the relevant load case in the settings of the nonlinear analysis and activate the button for the Phi-C reduction method. During the finite element computation, friction angle and cohesion are successively reduced until failure occurs. The resulting deformations and plastic strains are saved for each load step and therefore can easily be verified. This yield also for the shape of the slip surface, that becomes obvious by means of the plastic strain distribution. Please find also the reduced soil parameters and the corresponding factor of safety in the listings. In order to show the complete failure of the embankment and not only the limit case as predicted with the Phi-C reduction method, a second analysis is shown. The friction angle and cohesion are now set to a value lower than their limit value. Moreover, the solution method is changed from Newton to arc length to capture the post-critical behavior. After these adjustments, the simulation is started. Again, deformations, stresses and strains are saved for each load step. Optionally, an animation can be performed. Thank you for your attention.